Hey guys, in this video I'm going to show you how to solve this valid anagram problem. So problem statement says given two string s and t, return true if t is an anagram of s. What this means is that if we take the word s and we rearrange the letters, does that give us t? So for example, the dog, let me just write this here, dog, dog is the an or a anagram, whichever one. I think it's a, doesn't sound right. It's a anagram of the God, for example. And what this means is I can take the word God, rearrange it to get dog. So this makes dog an anagram of God. So we are going to be given two inputs, S and T. So S is the original word anagram and T is the anagram. So like it does also, like, the words don't have to like make sense so long as I can rearrange S to get T, report true, otherwise report false. For example, you could also have rat and car here. They're not anagrams of each other because, as you can see, you can't rearrange rat to get car because there's no C in rat, and yeah, so you return false. So if you think about this, for example, this rat case, you notice that they have this exact same length, but the characters are not the exact same. The number of distinct characters in each word are not the exact same. So we can work with that. We can also work off like the length of the word. So for example, the example I gave here, dog, is an anagram of God, and I could do a quick guess and say if T is if the length of T as a string is equal to the length of S, then we can assume that it's going to be an anagram of S. However, this is not always the case, just like we can see here, rat and car have the exact same length, but they're not anagrams of each other. So not only do we have to check for the length, we also have to check for to see that every character has the exact same frequency as in the original word that we're given. So if you look back at example 1, there's two A's in here, three A's rather. There's one A here, and another one, and another one here. And in the anagram, we also have three A's, right? One N here, one G, one R, one M. So if you can verify that the frequency is the exact same, then it must also mean that the length is the exact same. So we can work both of those things, two things. So the first thing I'm going to do here, hopefully that made sense. The first thing I'm going to do here is just do a quick check, say if length of S is not equal to length of T, because it's one of the requirements for it to be an anagram. If it's longer than or it's shorter, then it's definitely not an anagram, because it means that the frequency of each character, or the number of times each letter appears in C, is not the exact same as the number of times each letter appears in S, which it has to be the case for it to be an anagram of S. So that's why we are doing this check here, to just quickly eliminate those ones that are not anagrams at all right off the bat. So if line of S is not equals to line of T, then we can return false straight. Then I will create a map to keep track of, let me call this frequency map. I'll create a map to keep track of the frequency of each character in each word. And now what we're going to do, we're just going to loop through S and T, and then store the frequencies of each character in there. So a simple for loop for each character in S. So we'll do a check to see if the character is already in the frequency map. So if char in frequency map, then we are just going to increment it. So if it's already there, so for example, if we've seen A inside, sorry about that. If you've seen A in the map already, then we can. So the first time we add an A, there's no A in there, so we'll add it. But if we've seen 8 already, then we just need to increase like the count. This will make sense in a minute. Let's just write this. So I'm just going to do frequency map char plus equals 1. Else we will set a key of char equals 1. So the first time we see A, we set the count or the frequency to 1, and anytime we see A again, then we just increase it. Basically, what we are aiming to achieve is something like this. If what I'm saying doesn't make sense yet, what I'm trying to achieve is something like uh, something like this. So here we have. Why am I putting comments everywhere? You know what? Just let me try. So for example, in this S here, there's 3 A's. So we want a hash map that looks something like this. Then there's 1G. There's 1R. A frequency, a frequency map like this, exactly like this. This is what we're trying to do. So that's what this for loop block will do. Now, once we're done with this, we want to also we now want to verify that, hey, does T have the exact same thing as S, the exact same occurrence or frequency of characters as S has. So we can easily do this by using another for loop. So I'll do the same thing here. Char T. So one thing I'll do is I'll check if there's a character in C that doesn't exist in our map. Our map now has every single character in S with their frequencies. If there's any character in C that doesn't exist in map, then we can immediately stop looking for that, because it means that it's not an anagram. Imagine like we had an S inside of C here. It's not in the map, so obviously it's not an anagram. So we're going to say if char not in frequency map, just return false, so it will break immediately and exit the loop. However, if it's there, what we're going to do is do frequency map char, then we subtract 1 from it. And this is useful. You see why this is useful in the end, because it just means that we're able to verify that, hey, then we found the first A in C that also exists in S. So we keep doing that and keep subtracting, so that at the end of this, our frequency map, which used to look like this before, would now have, obviously there's more stuff inside of it, would now have something like this at the end of it. It's now be A equals to 0. This will be A maps to 0. This is what we are gunning for. So if it's the case that every single character in our map now has a value of 0 at the end of both for loops, then we have a valid anagram, because it means that there's a match for every single character in C in S, meaning that the number of frequencies is the exact same thing. So I'm just going to do that till that's what this for loop is just going to do. So at the end of everything, what we're now going to do is return. We're going to return. 1 second. So yeah, we're going to return the. So we just want to check to make sure that every single character, like I said, every single character in our frequency map is now mapped to 0. And one way we can do that, we can just do check if the maximum value of frequency map dot values, which is all of the values in our dictionary. Yeah, when I say map, I mean in Python. I'm writing Python, so it's a dictionary. So frequency map with values, check if it's equal to zero. So if it's equal to zero, then yes, this is an anagram. If it's not equal to zero, then it's not an anagram. So hopefully that makes sense. Yeah. So let's run this. Yeah, and you see, like it passed. Cases. Submit. Yeah, there we go. Accepted. So, and that's how you solve the valid anagram problem. See you next time. Bye.